Today we're going to talk about pedigree analysis. And pedigree analysis is essentially a family tree that shows how traits are transmitted from one generation to the next. Because it's not possible to mate humans together, scientists studied interesting traits in families. And they would get lots of information on all the relatives, and they would build a pedigree or family tree and use that to figure out how these traits were inherited, or in other words, what the mode of inheritance was. Today we're going to go over that information. Now, in real life, people that do pedigree analyses have a master's degree in genetics. That's beyond what we're actually going to talk about today. What we're going to talk about today is just an introductory level pedigree. And I'm going to start out by giving you a flowchart, a place to begin. Now, this flowchart is not going to be 100% accurate all the time. That's why there's people with master's degrees in genetics. But this flowchart I'm going to give you is a good place to begin your education on pedigrees. So let's go ahead and start there. So I'm going to start by writing pedigree analysis. That's where we're going to begin. So pedigree analysis. And from there, we're going to break all pedigrees up into two types. A dominant and recessive. So dominant traits and recessive traits. That's the first thing I want you to do, is figure out whether this pedigree is dominant or recessive. How are we going to do that? Well, we're going to start out by seeing if it's actually dominant. And if it is, all affected individuals are going to have an affected parent. So all affected individuals have an affected parent. If that's true, then we're going to assume that it's dominant. If that's not true, then we're going to assume that it's recessive. After we determine whether the trait is dominant or recessive, we're then going to break it up a little further into Xlinked or autosomal. Let's go ahead and write that down. Xlinked. And Xlinked means that the gene for that particular trait is located on the X chromosome. That's what Xlinked means. If it was Y-linked, that would mean that the gene for that trait is located on the Y chromosome. If something is sex-linked, that simply means that it's located on the sex chromosomes, either the X chromosome or the Y chromosome. Today we're simply going to deal with X-linked traits. Now we've got autosomal, X-linked, and autosomal. So let's assume that we determine the trait is recessive. Once we've determined that the trait is recessive, we now have to determine, is it X-linked or autosomal. If it mostly affects males, then we're going to assume that it's X-linked. The reason is because males only have one X chromosome. So if they get a bad gene on the X chromosome, they're going to have that particular trait. With females, it's a little bit different because females have two X chromosomes. So if they get a bad gene, for example, color blindness on the X chromosome, chances are the other gene on the other X chromosome is going to be good. So if it's X-linked recessive, it typically mostly affects males. It will affect females if they have two bad genes on the X chromosome, which is rare but can happen. If it doesn't mostly affect males, then we're going to assume that it's autosomal. So if it affects around 50-50, plus or minus, we're going to go with autosomal. Now, what if it's actually a dominant trait? Well, that one's just a little bit more complicated, but let's go ahead and go through it. First of all affected males are going to have an affected mother. So we'll write that down. All affected males have an affected mother. And the reason that is because males only have one X chromosome. So if mom gives them that bad X chromosome, they're going to have that particular trait. Now dad can't give that bad X chromosome to a male, to his son, because dad only gives the Y chromosome to his son. If this is true, then we're going to go on to the next criterion. If this is false, then we're going to go with autosomal dominant. Now, what's the second one? When the father is affected, all his daughters are going to be affected. Because dad, if he's got a bad X chromosome, when dad has a daughter, he gives that daughter his bad X chromosome. Because he only has one X chromosome to give. So if it's bad, his daughter's going to get it. And B, no sons affected. And the reason that no sons are affected is because we're talking about the X chromosome here. And if dad has a son, then dad's going to pass on the Y chromosome to his sons, not the X. So the sons won't be affected. So again, if we find out that we're dealing with a dominant trait, we're going to go through these different criteria. If all these criteria are true, we're going to assume that it's X-linked dominant. If any one of these criteria are false, then we're going to assume that it's autosomal dominant. So again, we're dealing with 4 traits today. X-linked dominant, autosomal dominant, X-linked recessive, and autosomal recessive. Now I want to go ahead and give you one more small flow chart to talk about chromosomes. So let's go ahead and write that here. Humans. A normal human has 46 chromosomes. And out of those 46, 44 are going to be what we call autosomes. Autosomes are chromosomes that both males and females have in common. The other 2 chromosomes are going to be sex chromosomes. So 2 sex chromosomes. And these sex chromosomes, just like their name implies, are going to have to do with sex determination. Out of these 2 sex chromosomes, we could have 2 different versions. Somebody could have XX, in which case that somebody is a female. If they have XY, then that somebody is a male. The Y chromosome actually carries genes that determine maleness. So if an individual has a Y chromosome, they're a male. I don't care how many X chromosomes that individual has. If they have a Y chromosome, they're going to be a male. And that's it for pedigree analysis. On the next videos, we'll go into each one of these particular modes of transmission.